All right. Good afternoon, everybody, and thanks for being here. Welcome to our June 2026 installment of ENERCALC Office Hours. As always, we have a couple of housekeeping items that we're going to go through before we start our session. First, I want to start with a quick sound check. If you can direct your attention to the bottom menu of the Zoom window in your browser or your app, you'll see that we have a chat tool. We also have some reaction capabilities. If you can hear me right now, I'd love to see some reactions, thumbs up, okay. All right, I see some movement. Thanks for confirming that, everybody. And now we also want to do a sound check and a visual check for our primary speaker. Seth is going to go ahead and take over the screen share. And if you can hear Seth's voice in a minute and see his screen, go ahead and give another thumbs up or an okay.
All right. Thanks, Chelsea. Thank you guys for being here. I'm excited for today's program.
Beautiful. Looks like we're getting some good reactions. We got an audio good. All right. So now that we have those tech checks out of the way, we're going to go ahead and disable the chat, and then we'll move on to some intros and get going with our program. So my name is Chelsea Darnell Jong. I'm a product engineer here at ENERCALC, and our presenter for this month's Office Hours program is Seth Rossworm. Seth is a senior structural engineer and a software developer here at ENERCALC. He divides his time between software development. He is the creator and lead developer of ENERCALC for Revit, so a perfect fit for today's session. He also does other software development for ENERCALC, and he works with the ENERCALC engineering team on the specifications and behavior of our software. And he also helps to maintain a presence for ENERCALC at regional and national events. And for anyone who's new here this month, the Office Hours program is meant to provide a line of communication between our ENERCALC engineering team and the ENERCALC users. This program is meant to do a few things. We like to showcase new features and updates from ENERCALC, show some optimized design workflows, go through some hands-on examples, and then we always have a live Q&A. To submit a question for today's Q&A, please use the Q&A dialog in the lower dashboard of your window. And during the Q&A portion, if a question is too involved or requires deeper digging, we might just let you know that it would be a better fit for our support team because they can investigate your concerns and take a deeper dive, a look under the hood to provide more answers to some of those more complicated questions. So we'll go through that when we get to that. But if you ever want to rewatch today's session or share it with someone in your office that you think might benefit from it, the recording is going to be posted on the Office Hours playlist on ENERCALC's YouTube channel, as well as the Office Hours page on ENERCALC's website. And then with that, I'm going to go ahead and hand it over to Seth, and we'll get going on our program.
All right. Thanks, Chelsea, for the introduction. And thank you, everybody, for being here. I'm excited to be sitting on the other side of the desk for today's session. Mac is a hard act to follow, but I'll see if I can maintain the standard you guys are used to. So let's go ahead and get into today's program. We'll start off with just a brief agenda of what we're going to be covering today. As always, we'll quickly go through our PDH certificate announcement, where we always break out some time to let you guys know what's new, what's the latest, greatest going on in ENERCALC. Our main program for today is all about wood building design using ENERCALC for Revit. And so we're going to spend the bulk of our time on that today. And like Chelsea said, that's a topic that's dear to my heart since I'm the creator and lead developer of ENERCALC for Revit. So ask your hardest questions. I can't wait. And then obviously we want to remind everybody to go ahead and register for office hours to get notified and reminded of future events. And as always, we'll close it out with some live Q&A with the audience. So have your questions ready. Use your Q&A dialogue to get those in as we go. So just to briefly touch on our PDH announcement, we do offer half hour of PDH to live attendees, and that's to represent the guaranteed technical portion of the presentation. The name we use on that certificate is going to be the name that you used to join the Zoom session today. So just make sure that you use the name that you want printed on your certificate. I do believe that you can change that name easily enough without leaving the session and rejoining. You should be able to edit that. So just make sure you have that set the way you want it. And you'll get a link to download that certificate by email in a few days after the session. So first and foremost, we always want to touch on the latest build of ENERCALC and make sure that you guys are using the latest, greatest. So we did actually roll an update this month. And so the latest, greatest build as of today is not 2605, which was our previous latest build last month, but today the latest, greatest build would be 20.260608. So 2 days ago, we rolled the latest update. And there's a couple different ways you guys can always access those updates within the software. You should get reminded automatically when ENERCALC fires up when there's updates available. You can also use the update button that I've indicated here to go and access the updating options where you can check the box to automatically get reminded for updates at startup, to manually check for updates. And then you can always visit our website as well if you want to just go ahead and manually update either a full installer or an update installer for the latest, greatest. And we're typically on a schedule of updating either once or twice every single month throughout the year, which means there's a lot of great features coming out about every 2 weeks. And we do want to remind you guys still that if you have a build number that falls between August 30th, 2023 and February 28th, 2024, you do need to go and get that update manually one time, and then you'll be able to update automatically from there. And for those of you who may have not heard that you can actually subscribe to update emails to get our release notes every time we roll an update, there is a page on our website where you can go and subscribe to that as well. So you can get reminded and get a copy of the release notes every time we roll a new version. So let's touch on some new features. What's the latest, greatest in ENERCALC? Just so that you know what you're missing if you haven't updated, or what you maybe haven't explored even if you are up to date. We're just going to go through a few things. Some of these you've heard before. Some of them are brand new. So everyone should be aware by now that in ENERCALC, we have completely decoupled your building code design standard selections so that you have an a la carte capability to pick each of your reference design standards rather than those being tied to a specific IBC. So formerly in ENERCALC, you would pick an IBC version, all the reference standards would come along with that. Those have now been fully decoupled so that you can pick and choose which design standards you want to use. And that just provides a lot more flexibility for our customers who work in different jurisdictions with differing approaches to adoption. But you do have the ability to sync those settings back to a given IBC standard if you choose to do so. And of course, for anyone who's attended our previous sessions, you know that Mac has been raising awareness for a long time about what we call load linking capabilities in ENERCALC. There's a lot of literature and a lot of training sessions out about this now, but we do want to make sure that everybody's aware. If you're using ENERCALC in your daily workflows today for design of beams, columns, and general footings, you absolutely should be using load linking, which allows you to seamlessly connect your individual calculations to each other using reactions as applied loads in downstream calculations. Create durable dynamic relationships between your individual calculations, ripple changes down the load path, automatically associate those calculations without having to scribble, screenshot, or copy and paste those forces. And we do have some really good training sessions out about those. In fact, I believe we have 2 prior office hours sessions now in the last 24 months that are fully dedicated to load linking capabilities. And that takes you all the way up through linking beam to girder to column to general footing. Another feature that's relatively new that's been spreading throughout ENERCALC output features, which should be, I think, fully implemented throughout the entire program at this point, is the ability to export tabular design results or analysis results from any table that looks like what you guys see on screen right now. You have a right-click context menu where you can simply right-click and either do a save as or copy to clipboard and get CSV formatted data from those tables to post-process on your own, generate reports, do additional analysis, what have you. Another new feature that we're pretty excited about that actually came from an office hours session feature request is this keyword search capability to make it easier to traverse your project manager for a given project. As your projects grow, 30, 40, 50 calculations, we know for a fact we have ENERCALC customers who put 150 to 200 calculations in a project file. it gets more and more difficult to traverse that project file and find the specific calculations you're looking for. And we're really excited to remind you guys that we now have a filter by keyword capability that lets you quickly and easily find specific calculations or divisions by keyword search in your project manager. So make sure you guys are taking advantage of that as your project files grow. Another feature that's new this month, some of you may be aware that we have an AI-powered chatbot to assist you with getting support answers on, nights and weekends, and when you need quick answers when human support may not be readily available. We now have a shortcut directly inside the ENERCALC application where you can go and click the Ask Jack button, which will redirect you directly to our chat interaction. You can ask questions, technical questions about the behavior of the software, questions about links and wayfinding for the website, for licensing and e-commerce questions, a variety of different things. But you can now redirect to that site directly from that button inside ENERCALC itself. All right, well, I think that pretty much wraps up our front matter, and we want to move on to the topic of today's session, which is the wood column module, the wood beam module, and how they directly relate to the Revit environment. So we're going to talk about ENERCALC for Revit and specifically for wood buildings. I want to give you just a quick overview of what ENERCALC for Revit is all about, and this schematic does a pretty good job of overviewing that. Basically, what we're talking about is going from Revit geometry, easily launching a calculation into the ENERCALC environment that you're used to interacting with, make design decisions, and then push the results of those design decisions back into your Revit environment via section size changes, reaction forces, parametric information to tag and schedule, and so on. And we're going to be specifically talking about how this applies to wood buildings, though we do have a variety of capabilities. So going to talk just briefly about what ENERCALC for Revit is and what it isn't. Obviously, this is an era in the structural engineering industry where workflow gaps are a big thing that people experience. And so that's what ENERCALC for Revit is all about, trying to bridge gaps in your workflow, specifically between drawings or documentation environment and calculations. So we're looking at using an intuitive Revit-based interface and leveraging key information from Revit to shorten your design process. So we're accelerating the use of ENERCALC to do the same component-based designs that you guys have always done in ENERCALC, not intended to be a replacement for global analysis tools. This is not a replacement for whole system analysis via finite element, but it's to facilitate and speed up your component-based designs. And then also because we're in that rich graphical environment, we have the opportunity to do things like change tracking, manage and overview your calculations, minimize those transcription errors by using numerical information directly from your Revit environment, and keep your calculations and your model up to date with each other. So we're going to go through just a few very quick overviews of what ENERCALC for Revit looks and feels like, and then we'll dive into some wood-specific workflows. And again, as you guys have questions as we go through our session, make sure to use the Q&A dialogue and get those questions rolling so we can tackle them at the end. So the first thing to know about ENERCALC for Revit is just this intuitive Revit-based interface. When you get into the Revit environment, the same place you find your structure tools, your annotation, collaboration tools, you'll find an entire new ribbon bar devoted to ENERCALC tools. And this is where you'll manage things like design properties, overview calculations, view design status, set design inputs, and then actually launch and create and open calculations in your model. ENERCALC for Revit uses what we call a point and click or a one-click launch process, where you're basically just point and click interacting with physical Revit elements and generating calculations from them. So that starts, when you do that point and click process, it starts a sort of a wizard-based launch process where we're using information in the model, things like support conditions, member intersections, to build your span geometry, looking at load path things like tributary framing conditions, and then taking all that information directly into your calculation environment, giving you a fully built calculation that's ready to interact with and design from. But as we mentioned earlier, because Revit is such a visually oriented environment, this opens up the door for a lot of overview and calculation management capabilities like color-coded highlighting of pass and fail conditions, warning states or status conditions, as well as tabular information. Uh, Calculation reports. We'll look later in our session today for how to pull calculation reports from directly inside ENERCALC for Revit. And then the element manager window also gives you two-way selection so you can easily see which calculation correlates to which physical modeled element and vice versa. Now, if there's one thing that never changes about a structural Revit model, it's that it's going to change over time. And so ENERCALC for Revit keeps you on top of those changes as things are evolving. You make geometric changes or design changes. You have the ability to be aware when those changes affect your ENERCALC calculations you've already established. And you're going to be able to see granular information about the nature of those changes as they occur. And when those changes and evolutions do occur over time in a Revit model, you're going to have the ability to easily regenerate and refresh those calculations on the fly with a suite of recalculation tools that are found directly inside your Revit model, right on the ribbon bar, instead of having to go out and manually refresh or regenerate those calculations one at a time. So when it comes to version support, ENERCALC for Revit makes a policy of supporting the same 4 versions that Autodesk supports. And so right now, today, that's Revit 24, 25, 26, and 27. Autodesk typically releases a new Revit version every April. And so this year, just like every year, we provide day 1 support for the latest version. Whenever Revit 2028 rolls out next April, then we'll end support for 2024, and the supported versions would be 25, 26, 27, 28. So let's go ahead and talk about some wood building Revit workflows. I'm just going to give a quick overview of our topics for today. What are the workflows we're going to examine, and then we'll dive into those one at a time. So we're going to start out talking about reference design values. Obviously, for those who do wood design, the actual reference design values are the cornerstone of that. They're very foundational to that workflow. So we're going to start by talking about how we assign and manage our materials and our reference design values. Then when it comes to practical design workflows, we're going to start out talking about repetitive joist systems. That's a pretty much a staple in wood frame design. From there, we're going to move into talking about headers and girders. We're also going to talk about columns, posts, and stud design using ENERCALC for Revit in the Revit environment to accelerate workflows you already do manually in ENERCALC today. Also going to talk about transfer post conditions, where we take a column with load in it, drop it onto a girder, and then take that force further down in the building. And then we'll have an opportunity to talk about engineered wood products as well. Obviously, for those of you who've been doing wood design for a long time in ENERCALC, you know that we support a variety of engineered wood products, including LSL, LVL, PSL, and so on from several manufacturers. We're going to talk about today how you can take advantage of those capabilities inside the Revit environment. So we're going to start out by just talking about the building blocks of a wood calculation, specifically as it relates to ENERCALC for Revit. All of these are familiar if you're already designing wood beams and wood columns in ENERCALC, but we're going to talk a little bit about the fundamentals, the ingredients that go into building a wood calculation, whether that's a beam or a column or what have you. So obviously, first and foremost, you're going to need to have some fundamental span geometry information, support conditions, distance between supports, which gives rise to our span lengths. Some loading information is a part of that as well. And ENERCALC for Revit extracts all this information from the physical model on the fly as we interact with that launch process that we saw earlier. And of course, as part of that first category, you also need loading information. Loads can come either from the Revit model or they can be inserted in the ENERCALC interface, just like you would for a conventional manually built calculation. That's pretty much just a matter of taste and workflow preference, whether you create those loads in Revit or whether you create them in ENERCALC. And we're going to look a little bit at both of those options. Next up, obviously, you're going to need some kind of section geometry. What cross-section does the beam have or the column have? And regarding section types and sizes, all the ENERCALC for Revit behavior you guys are seeing today supports all the major wood section types. So that means dimension lumber, timber sections, Western and Southern glulam sections, and then engineered products as well. And then finally, you need the NDS reference design values, which we talked about just a moment ago. We're going to dive straight in here in a second, talking about how we manage those, how we assign them, and then how they actually make their way into your calculation. So let's go ahead and dive into talking about reference design values. Obviously, reference design values are pretty foundational to your design process. ENERCALC for Revit gives you some really nice workflows for assigning those in mass across a structure, so you don't have to continue assigning them individually, calculation by calculation. Now, the first thing to know about reference design values is that obviously they do vary a bit by the NDS version year. They're not perfectly the same from year to year. So the first thing we're going to want to do in a project is go visit the EFR preferences menu and select an NDS version year. So we talked earlier about that ribbon bar at the top of your window. This is where you would go if you're going to assign a file linking relationship to say, hey, I want all my calculations to go to this ENERCALC project file. In that same menu, we can access under the Active Model Preferences on the Materials tab a setting for the NDS version year. So this is what's going to determine which specific set of reference design values EFR chooses from to send to ENERCALC when you launch with a given combination of table, species, size, and commercial grade. So once you got an NDS version set, we can actually dive into creating some material definitions from the Edit Wood Materials menu. And we can easily access the Wood Materials menu from the Wood Beam button at the drop-down, or from the Wood Column button, where there's a similar drop-down, or we can go directly to the Edit Design Properties window, navigate to the Wood tab, and expand that table. And when we're creating a new material definition, that's as easy as just adding a new row and then walking down the cascading NDS options. So when I go to add a new row, I can give this material definition a name. I can choose which NDS table. That gives us a list of available species. The species gives us a set of available size classes per the NDS tables. That's going to give us a set of commercial grades once we choose a size class, and then we can just save these changes. Now we have a material definition that's ready to assign to physical elements in our Revit model. So once you've created some material definitions, you can go ahead and assign them to any number of physical elements in the model. And this allows us to bulk set our design properties and then proceed through the design of many elements without having to actually stop and specify a different material for each individual element you launch. So to assign a material to an element, we can just pick that row in the table and click Apply to Elements. This will trigger a selection workflow where we can pick, either singly pick or loop elements, and then click Finish on the ribbon bar when we're done. And when that definition is applied to the newly selected elements, then the quantity count in the table will update. So we know that we have 14 elements assigned to that second floor joist material definition. And if you want to overview existing material assignments at any point in the life of a project, you can do that from the Edit Properties window, the same window where we were just creating and assigning those properties. You can simply walk down the table row by row, and it'll actually show you the physical elements in the model which currently use each definition. So in this case, we can see our second floor joist material. We can see our main entrance timbers material. We can see our main entrance rafters material that we assigned. And we can see our wall stud materials and so on. So these have already been assigned, but we can go back, walk down them, and see some real-time awareness of how the model has been set up. All right, so now that we've covered some background about managing our design values, let's go ahead and dive into some practical workflows. So we mentioned earlier that we're going to start by talking about repetitive joist systems, and repeated framing or repetitive joist systems are pretty much in the DNA of wood frame construction. It's something that you run into every project because that's just how wood frame buildings work. So we're going to walk through a couple different approaches to not only design your joist faster, but then also to come back after design and manage your Revit model faster as well. So in our first example here, we have a group of joists that have been roughly modeled, but they don't have final sizing yet. And our first step is just to do a point and click launch for one of those joists. We're going to choose a typical joist. And when we start that launch process, ENERCALC for Revit is going to lead us through several steps of verifying inputs, including our support conditions, framing conditions, and then build a calculation for us. So in this case, we have two bearing walls nearby. And when we do the launch process for this particular element, ENERCALC for Revit detects those bearing walls. This is what we're going to use to build our span geometry. This will be a simple span joist that spans from wall to wall. We don't have anything framing into this joist, so we'll pass over the tributary selection. So as soon as we finish those very quick approval steps, calculation seamlessly loads into ENERCALC. And now we actually have span geometry. We've got preliminary section size, material properties all set up and ready for final design. Because we previously had already assigned a material, we got the section size from the name of that type that was already on that Revit element, and now we have a calculation that's ready to interact with. Now, the really cool thing about this workflow is that once your calculation launches, you're now back in the same familiar environment that you've always used as an ENERCALC user. So now that we're in this calculation, we can do basic design tasks like naming our calculation. We can go ahead and throw some loads on this joist. I'm just going to give it 20 PSF dead, and we're going to give it 40 PSF live, give it some tributary width. Again, we could have set some conditions in Revit to bring these load conditions over automatically. We're just doing it manually in this case. Then we can also look at our loading diagrams. We can look at our Unity check performance, and we can go ahead and go to our selection picker and walk down and find a more appropriate final joist size for this framing member. And now when we save and close, ENERCALC for Revit is going to take this joist size we've just assigned in the ENERCALC calculation and go ahead and push it straight back to our Revit model. And so you can see where we had the preliminary 2x4 sizing here, the one that we were designing has actually been toggled automatically to a 2x8. So the steps we just finished only address one joist in the whole floor area, but EFR does have some nice capabilities that let us rapidly propagate those design decisions across multiple different elements within our building. So we can do that using what ENERCALC for Revit calls parent-child groupings, which are found in the Element Manager window. So if we go and pick this calculation in the Element Manager, we can navigate to the Child Elements tab and hit this button that says Add Child Elements. So we can simply go and pick other elements that we want to follow the design of this parent beam. So as soon as we do that, we see that all of those joists in mass automatically toggle to the right size. They show us green highlighting that says they have a design associated with them. And then we can actually browse those individual child elements right here in the table. And the really cool thing about parent-child groupings is that it gives us a durable means to manage bulk design settings over time. So that means if the design of the parent calculation needs revising or changing at any point, the child elements are going to seamlessly follow along. So we can actually see that here by just simply toggling to a different section size on our existing parent joist. If I take that 2x8 and I toggle it to a 2x12, we'll get a pop-up that says, hey, are you sure you want to make that change? When we do make that change, we go into a warning state that says, hey, your calcs don't agree with your physical model. I can use the recalculation button to refresh on the fly, and then all of our child elements automatically update to that new size, and they show the new design status based on the updated analysis of that beam. So for our second example, I want to talk about beam systems, and there's a pretty good chance that example 2 answers the first question that came to your mind when I mentioned repeated framing, because beam systems are one of the biggest ways that engineering teams tend to tackle repeated framing systems. Some engineering teams like to use Revit beam systems, some teams don't, but no matter which camp you're in, it's definitely helpful to know that ENERCALC for Revit parent-child does interact very cleanly with Revit beam systems. So in this case, at the end of this second story corridor, we have a place where the header bumps out, the corridor widens, and we just have this very small system of a handful of beams tied together as a structural beam system in Revit. So like we did before, I'm going to start out just selecting a typical joist in this area that we want to tackle. The launch process for this beam is going to go just like it did before, but there's going to be just one subtle twist to it, and that is ENERCALC for Revit can detect on the fly during launch that the element I selected is part of a beam system. And so during the approval interactions, in addition to saying like, hey, these are my supports, these are my framing conditions, we're also going to be given the option to go ahead and set all the other beams in the system as children of the main beam that I'm launching. So when we go ahead and pick this beam, obviously we have our header and our wall as the support elements that we're bearing on. And then we see this extra step here, says the selected beam is part of a beam system. Do you want to go ahead and assign those as children? And as an added perk, you definitely have the option to manually cherry pick only certain members if that's what you want to do. You don't have to take all the members of that beam system. You can manually pick one or two, just a few, what have you. And now again, we have a fully built calculation that's ready to interact with. Same drill with our basic design tasks here in ENERCALC. This is workflows you guys are familiar with. Nothing unique about this because it's fundamental ENERCALC workflows. So we're setting loading, we're setting some trib width, interacting with our design calculations. But the key difference is what happens once we save and close. So we find out our 2x6 size works just fine for this corridor. When we hit save and close, we're going to see not just the parent beam, but also all of the child beams automatically resize when we save and close. And so everything moves down from our preliminary 2x8 size down to a 2x6, which is our optimized size. And we didn't have to make a bunch of markups and hand them to a BIM tech. We didn't have to go through and manually toggle all those ourselves. We're just using that parametric relationship of the fact that they're a parent-child group and update them all in real time. So from there, I want to go ahead and dive into headers and girders, and we're going to springboard from that example we just talked about to kind of get our feet wet with talking about headers and girders. Now, you guys have heard us talk a lot about load linking. There's some similar load linking capabilities here in ENERCALC for Revit that are similarly intuitive, but even a little bit smoother to use on the fly because we're taking advantage of the spatial connective relationships in the Revit model. So if we come back to this same header from our example that we looked at just a moment ago, we can just relaunch this header, or excuse me, we can't just launch a calculation for this header knowing that we already designed one of these beams, right? We know that we already designed the typical beam from this system. And so if we directly launch the header calculation, we have the two bearing walls, the header spans from wall to wall, and then we have these tributary elements that frame in, which ENERCALC for Revit can associate on the fly and bring those forces in. So if we go to our loading diagram, we only see one force dropping on this girder right here, and that's because that was the one that we designed. And that's nice, it's kind of cool, but it's not really the full picture for what's happening on that header. So the question is, what do we need to do about that? And to answer that question, I want to go ahead and revisit the concept of parent-child groupings one more time because there's another level to those parent-child associations that we didn't touch on in our previous two examples. And that is the ability to actually let the child beams follow not only the section sizing of the parent, but also the end reaction magnitudes of the parent. And so if we go look at this, go back to our element manager for this corridor group here, we can go to the child elements tab and you see that these say reactions are not copied from parent. So I can actually clear out these child elements and reassociate them, but this time using the checkbox that says copy reactions from parent to child. And so if I go ahead and do that, then it'll repopulate this table. This time we see that it is copying reactions from parent. It says yes in the table. And what this means is each one of those individual joists has data stored on it that shows us what those reaction forces are so that we can use those reactions on the fly for downstream element calculations. So what does that look like? Well, we can go back and again relaunch this header calculation. And when we do that, we're going to see that because we say, yes, these are my support conditions, yes, these are my tributary framing elements, ENERCALC for Revit can actually take those reaction forces and associate them on the fly to your beam calculation. So now that our header is fully loaded with each of those joist reactions from the corridor, Now we can do an accurate design, a final sizing that actually considers the true structural effects that this header feels. We didn't have to go and copy and paste. We didn't have to manually apply those loads, but we do have the ability to get an accurate design on the fly. And you can also see as a side benefit of this example that we were able to directly interop to a 2-gang 2x12 as long as you have a family with the proper naming in your project file. So we already had a 2-2x12. We were able to assign that, and ENERCALC for Revit could assign it on the fly, even though it's multiple ply dimension lumber instead of a single ply. Now, that previous example kind of hinged on the fact that we were transferring forces from another calculation that we've already worked with, right? So we had already done that corridor joist design. We already had some reaction forces. We had kind of kickstarted that process. But ENERCALC for Revit also has some nice capabilities to accelerate your workflow, even when you don't already have upstream calculation information. So and I also want to highlight this particular girder design because it shows a little bit of more complicated geometry, different support conditions, and so on. So if we look at our main entrance area on this building, our girders that support this main entrance bump out from the building. This is actually a 2-span condition with 3 supports, 2 columns, and a bearing wall. And ENERCALC for Revit is able to detect that condition and suggest it. And we also see that our rafters are detected as tributary framing elements that may dump load onto this girder. So when we launch this calculation, we do see our 2-span geometry, but we didn't have any loads. And so I canceled out of that because we're not ready to do design yet unless I wanted to go manually load that element. Individual point loads, approximate it with a linear load, what have you. Instead of doing that, what we're going to do is take a look at a time-saving capability that ENERCALC for Revit calls the girder point load generator. And the girder point load generator allows you to use the real geometry of the Revit model with critical information like the spacing of rafters, the spacing of joists, the spacing of floor beams, the span of those beams, and use that to determine accurate reaction forces that those beams would apply to the girder, generate those loads, and then proceed directly to the girder design without having to have upstream designs for a variety of different elements. So we're going to look at this same girder on our main entrance and use the girder point load generator tool. So we can come in here and pick this girder, detect our support conditions, detect our tributaries. And what the girder point load tool does is it actually builds us a reaction table where we can manually input area load magnitudes. We're going to put in some dead load, some roof live load. We're going to put in some snow load, and then we can actually just copy these down and use the same area loads for all joists. And we see a preview of the actual reaction magnitudes that are going to be generated. So what this is doing is it's actually generating physical, analytical point loads in the Revit environment at the appropriate locations where those joists intersect the girder. Now that those loads have been generated, I can relaunch the girder calculation for this 2-span girder that projects out of the building, and we can go ahead and do a design for that girder without having painstakingly designed every element that bears on it. So let's take a look at that. Now that we have girder point loads, we'll go ahead and relaunch. And again, even though we have a more complicated support condition, ENERCALC for Revit automatically says, hey, it looks like you have a column wall condition, which we do. It detects the tributaries. And now when our calculation loads, in addition to our complete 2-span geometry, we also have all of our point loads generated from those joists. We also have all of our reaction forces. Those reaction forces will become significant for downstream designs like doing our columns. We could change our section size if we needed to. We can name this calculation. All those different design workflows you guys are used to doing. And now when we save and close and go back to the Revit environment, we can see our green highlighting that tells us our Unity check pass fail status. And we can also use the element manager to overview all of the calculations that we're beginning to accumulate within our project as we go along. We can also access reporting features directly inside Revit without going all the way out to the calculation environment where we have to open that calculation, manually print a report, and so on. So this kind of makes a natural jumping off point to talk about column workflows, because as we've been working our way through this main entrance element, obviously we have heavy timber beams that are holding up those rafters. We just designed one of those. And now it's a good time to talk about columns. We have two columns that we're helping support this girder. One of those is the interior column that has the maximum reaction. So I want to go ahead and go through those column workflows briefly and give you guys a taste of that. Obviously, you guys have been designing wood columns for a long time in ENERCALC, but this is going to give you an ability to do that seamlessly on the fly using the geometry that your team has already created in a Revit model. So in contrast to a beam where we're usually looking at span geometry, how far between supports, what are our fixity conditions, and so on. When we do this for columns, we're mainly talking about things like our slenderness profile, right? What are your brace point locations? What are your unbraced length? What are your effective length K factors, and so on. And so the column launch process gives you the ability to manage those things on the fly using information that's in your Revit model instead of having to just manually enter that information by hand data entry out of thin air. So since your engineering team, your CAD BIM team have already spent time modeling the structure, we're going to be able to just extract critical information for column design on the fly. And here's what that looks like. Tell ENERCALC for Revit we want to launch a column calculation, and we can see things like a relationship with a support foundation, a K value, and an unbraced length about both the X and the Y axis, and then elements that are tributary to this column with respect to gravity force transfer. And so when we do that, we can go to our 2D loading diagram and see that the axial force that was the interior reaction from that two-span girder has been transferred directly to the top of our column. We can see that our section size, our unbraced height, all these things have come automatically into our calculation, and the slenderness profile as well. In this case, we were using K equals 1 with full column height for the unbraced length. So we're kind of building the load path as we go. We took reactions from rafters, put those reactions on a girder, did a girder calculation on the fly, and now a column calculation. At this point, it's interesting to talk about the footing because we have an axial force from the column. We can actually, ENERCALC for Revit will allow you to seamlessly transfer that reaction force directly onto the footing. And we can even use that footing design to get back parametric information like size, length, width, thickness, and reinforcement in two directions so that we could even tag or schedule that footing. But that all starts with just doing a footing calculation launch using the same process as we've done before. So a general footing calculation is by far the simplest and fastest calculation to launch of all the things we've talked about so far today, just because the only real input that you have to worry about is, do you have a force transfer relationship with an element above, such as a column? In this case, we do. And then the rest is going to be extracted by ENERCALC for Revit on the fly. So we have length and width of the footing, we have thickness of the footing, we have some default reinforcement parameters, and then force transferred from a column. We'll be able to load this calculation and get it ready for your design team to interact with it and create final designs. So again, it's just a point and click launch process. In this case, ENERCALC for Revit is detecting, hey, it looks like this column is bearing on your foundation. And when we confirm that, then we'll see that ENERCALC for Revit automatically associates those axial forces from the column into the footing calculation. We can see things like our size. We can also modify the size of the footing. In this case, we're going to go down to a more optimal size of 4 foot by 4 foot, 16-inch footing. And then when we save and close ENERCALC for Revit, we'll actually go ahead and modify that footing size on the fly. And that can be done either by generating a new type if a new type is needed, or by toggling to an existing type if there's a type already found in your Revit model that meets the requirements you specified in the calculation. And we're not going to dive deep into tagging and scheduling and parametric information in this particular example, but because we had reinforcement information in our ENERCALC calculation, that includes bar size and bar quantity in both directions, in a rectangular case, long direction and short direction, or each way in a symmetrically reinforced footing. We do have the ability, because those are now stored in Revit's native parametric framework, we can tag those on the fly, we can schedule them, and you can have a complete, basically a complete data pipeline from your engineering calculations in ENERCALC all the way to your documentation for schedules on plans. The other header example, girder-like header example that we're going to touch on is, um, excuse me, over here in the stud wall area. And the thing that makes a stud just subtly different from a column that we just looked at a moment ago is mainly just because your bracing conditions are going to be drastically different about the two axes. Typically, if you're inside a wall, then you're going to be sheathed in one direction, and your column will essentially be fully braced in the weak axis and typically fully unbraced in the strong axis. And so we're going to go ahead and go through the process. Since we have done a header design already here, I went ahead and preliminarily sized some joists. I threw those joist reactions on a header. This header now has end reactions similar to the force transfer conditions we looked at a moment ago. That's going to allow me to go directly into sizing one of our studs at the end of this header. And we can launch that using an ENERCALC wood column launch, just like we did a second ago. And when we do that launch process, this time I'm going to specify some slightly different conditions where we're going to say k equals 1 overall column height about xx, and then fully braced about yy. And then we'll use our manual specified to say the header is what contributes force. And so when our calculation loads, now we see our 2x6 column. We've got our 2.7 kip axial force in the column, and we do see that it's fully braced about yy, whereas it's using full column height of that 10-foot stud about xx. Now we could go down and we could change this column geometry. In this case, because we're going to have jack studs and king studs, it'll be a stud gang. I'm toggling it to a 3-2x6. And because we already have a 3-2x6 type in our project, we can go ahead and load that on the fly, toggle it, and see our Unity check pass fail status. Now, I do want to touch on the concept of transfer posts, which are highly adjacent to columns. We are doing them using column calculations, but instead of the column bearing on a foundation, it's bearing on a superstructure element that's somewhere further up in the structure. And this is actually something that structural engineers run into a lot, regardless of what kind of building you're doing, whether you're doing wood structures, whether you're doing steel structures. As soon as we introduced steel column behavior several years ago in ENERCALC for Revit, one of the first questions we were getting from engineers is, we can do columns to ground. Can we do transfer columns? Can we do post on beam, kind of designs? And it's a pretty common design challenge. So I want to briefly touch on a couple different ways that you can tackle that. So turning our attention back to the main entrance example that we went through earlier, we do have, just like we have the girder at the eave that we designed, we also have a girder at the ridge. The girder at the ridge is two-span continuous because we have these two kind of king post configurations and the bearing wall at the face of the building. And so in my example, I've already designed that girder. It now has reaction forces. And so if I trigger a calculation for this, this front transfer post at the main entrance, we can again set our K factors and our lengths or unbraced lengths for buckling in the column. And we'll see that we have that large axial force being transferred from that ridge girder directly into our transfer post. We can go through design. If resizing was needed, we could modify the size here, and that would push back to ENERCALC. We already have our material properties that we assigned earlier. And so now we've quickly designed that post. We checked it to make sure it's okay, but we can also take that and springboard it because this post is supported on that girder below, we can now go ahead and check this transverse girder that's facing the main entrance. So if we now go back and launch a wood beam calculation, we can launch a calculation for that girder and manually specify which of these elements are supports and which are actually tributaries. And if I manually select that and use the checkbox that says remember this selection, then I don't have to make those clarifications over and over again. So now we can see the axial force in that transfer post is seamlessly transferred as a vertical applied load at the middle of our transfer girder on the front face of the building. We can actually toggle the size of that girder if we need to. In this case, we're going to 6x18 timber. And that size change will happen automatically when we save and close. And again, we have that green status highlighting that tells us, are we passing? Are we failing? What's our overall engineering capacity status? I mentioned earlier about engineered wood products, and I want to make sure that we touch on that before we get too far down to the end of our session today. So, obviously, engineered products are very, very important for a lot of things that structural engineers do, whether that's in residential, commercial construction, a lot of different use cases. It's pretty common to run into span configurations where regular dimension lumber is just not going to get you there. And that's where a lot of structural engineers always turn to using LVLs, using LSLs, PSLs, and so on. And we do know that ENERCALC has those capabilities. The ENERCALC supported materials that you have access to are found right here in the engineered wood products side of our database, where you can just go up and down that list from a variety of manufacturers. And so all you have to do if you want to make sure that what you have in Revit maps cleanly into ENERCALC is just make sure that you're specifying a combination of material properties in Revit that's in accordance with whatever product you want to use. So we can go back um, we can go back to the same workflow in our edit design properties window and go through that same process where we would specify instead of an NDS table that we're going to do engineered wood products. The species would be which specific category or manufacturer you want to design from, and then your specific grade, for example, timber strand, Versalam, and so on. And then when it comes to section geometry, obviously you want to make sure that you're choosing from a section geometry that ENERCALC itself supports. And so this would be your TJ microlam, TJ paralam, TJ timber strand, Versalam, ganglam, and so on. So you'll want to make sure that you're using Revit families and Revit types that have naming convention consistent with those things that you already know ENERCALC supports. So I'll just briefly go through an example here. My embedded video is seeming like it's not behaving, but the launch process is exactly the same as what you use for all of those other wood beams we went through. The only difference being that you want to make sure you have a section, a family type, a section naming, and a material definition that maps cleanly to what is found in the ENERCALC database. That's the only real distinction that you have to worry about. And once you do that, then you'll be able to map that calculation cleanly from your Revit model out to ENERCALC, make design decisions, even including changing things like changing an engineered wood material, changing an engineered wood section, push those changes back to your Revit model in real time. Before we wrap up, I do want to give you guys a heads up about upcoming events. Chelsea is on the road quite a bit this year, and her next stop is Structural Engineering Association of California, which, interestingly enough, is in Scottsdale, Arizona this time around, August 25th through the 28th. I'm guessing it'll be pretty warm for that, so hopefully Chelsea has fun in Scottsdale.
Yeah, I'll be sure to
Uh,
bring a bathing suit for that one.
bring you a fan or something. And we are about ready to open it up to live Q&A here. Just to quickly remind you what these QR codes are all about here, you can subscribe to our email newsletter, and you can also schedule a virtual training session for your team if you need specific guidance, especially for new users who are getting up and running with ENERCALC. And with that, I will go ahead and toss it back to Chelsea to see what we have in the Q&A.
Yeah, thank you, Seth. That was awesome. It's really exciting to see all these new wood workflows in ENERCALC for Revit. We do have some questions here. We're going to start off with, does EFR support or plan to support wood shear wall lateral designs from Revit models? So do we have any plans for lateral workflows?
Well, so yeah, so it's interesting that that would be a question that we hear, because I was specifically going to mention we're very, very interested to hear from everybody who's here today, and just from our user base in general. What are the tools that you guys want to see? What are the things you would use? Because I can tell you, there's the worst tool that we could possibly build is the tool that no one's asking for, right? So if that's something that you guys are interested in, if you want to see Revit integrated wood shear wall, absolutely reach out to us and get those votes in. Send us emails, light up the phones, because that's how things climb the leaderboard, and that's how we know that that those things are needed. As far as the specific feature, wood shear wall, it's not in active development right now, but it's something that we've been looking at for a long time. We've been looking at concepts like Revit-based diaphragm analysis so that you could get the lateral forces that go into your shear walls. And then obviously, because there's a lot of parametric data that we can get from wall elements, wall objects that are modeled in Revit, certainly has a huge amount of potential for things like story stacks, opening analysis, force transfer, and then basically performing your NDS wood shear wall checks. That's absolutely something that we've thought about, and so we would just basically say, hey, let us know if that's something that you guys are interested in, because we absolutely are interested in building the things that you guys want to see. So yeah, great question, and just reach out to us if that's something you guys want to see. We really crave feedback, and I was going to mention this early in the session and just didn't get a chance, but I'll mention it now. ENERCALC for Revit is a relatively young product compared to the rest of ENERCALC as a whole, and we want to continue to steer ENERCALC for Revit in a direction that makes it useful and powerful and highly relevant to your daily work. So we really depend on you guys to let us know what are those things that you want to see in the software. Great question. Sorry, Chelsea, that was a long answer.
That's okay. It's good to know. This was from an anonymous attendee, so if you would like to see a feature like that, or if anybody else in the session would like to see some features, please submit those to support@enercalc.com. Like Seth said, that does help us kind of gauge what things are useful. So yeah, go ahead and submit those feature requests, and we'll track them and see what people want and need.
Yeah, and we just always encourage you guys, don't look at this product and go, well, it is what it is and it's not what I need. We want this product to be whatever it needs to be to remain highly relevant to daily work for all of our customers. So we want to hear from you guys what those things are. And I just want to briefly mention, Chelsea, I see a couple of notices with raised hands. Everyone's muted right now, but if you have your hand up because there's something you're dying to ask, please put that in the Q&A.
Yes. Yeah, we actually just got a whole slew of Q&A. So let's jump through them.
Cool.
I'm planning to get Revit Lite, Revit LT. Will it work with ENERCALC for Revit?
Yeah, so we get this question frequently. Unfortunately, that's an Autodesk thing. So Autodesk does not allow does not allow Revit LT or Revit Lite, as some people call it, to be capable of running third-party add-ins. So the secret sauce that powers ENERCALC for Revit that you guys saw today is our plugin or add-in that goes into the Revit environment and powers that behavior. Autodesk doesn't allow Revit LT to run add-ins. So unfortunately, that's no, but it's also out of our hands and out of our control. So sorry, that's probably not the answer that people want to hear, but it's definitely a an Autodesk limitation and not an InnerCalc limitation. Good question though.
Yes. I
But
also
we
have a
have,
question.
sorry, just real quick, I'll mention we have had conversations with engineering teams where they're starting to reevaluate whether the productivity gains from working in an immersive way like this are compelling enough that it might be worthwhile to move people up from LT to full Revit, just so that they can do, more sophisticated engineering workflows.
Yes,
Sorry, go ahead, Chelsea.
that's all right. I have a question here from Danny. If I define loads in my Revit model, will EFR be able to automatically recognize those loads in that load path?
Yeah, great question. Absolutely. That's a big yes. And you might have been able to kind of see that in one of my slides. I'll just jump back really briefly here. When we started to look at that header, you can just kind of make out um, that we have some area loads placed on those joists, the red joists that are up above this header. There was just too much to cover today, and so I didn't do any granular hands-on examples involving Revit load interop. But the answer is yes, absolutely. There's a couple different things you can do. You can manually model linear loads and point loads on beams or columns. You can also put a structural floor with an appropriate span direction, put area loads on the floor, and then ENERCALC for Revit will evaluate those area loads, evaluate your tributary width, and automatically map those from an area load to a linear load. And that even includes more complicated situations like if you got a mechanical opening punched in the floor, you've got a deck edge that's varying. We can map that accurately into segmented linear loads in your ENERCALC calculation. So um, there's a lot more to do there. I want to say we have a couple of YouTube videos that touch on that just a little bit. We're planning to try and get more content out about these features over time, but that's a big yes. We just didn't have time to dive into it. You absolutely can do your loads in the Revit model.
Awesome. And then another question from Danny. If I define footing reinforcement in ENERCALC Revit, will it show up in your Revit model cross section?
Not at this time. And that was a careful design decision that we made just because at the time that we were building our general footing integration, and even today, I would say the engineering community was still very much divided about the concept of modeling rebar. There's a few companies that want to do it and they do it aggressively. And then there's still thousands and thousands of engineering firms out there who are like, don't you dare put rebar in my model. I don't want it in there. We don't want to slow down. We don't want to fiddle with it. And so at this time, our workflow for reinforcement is parametric only. So when you set that, let's jump back to that example real quick. When we did that footing design, I'll skip ahead in this video. When you get to this stage in the process where you can see on the left margin here, we have those bar sizes and bar quantities that have been set in this calculation. When I hit that save and close, those bar sizes and quantities are mapping back to parameters. And I can actually show you that in the Revit model. If I select this footing right here, let me, I guess, um, Chelsea, you can see my Revit model right now, right?
Yeah, I can see your Revit
Yeah,
model and
okay.
I see those parameters over
Yes.
off to
And
the
so we can,
side.
yeah, if you look in the properties pane, when we select this footing, you can actually see where those ENERCALC parameters have mapped back to here. And so if we actually go to a foundation plan, we can jump in here and actually tag this. We can toggle this to an ENERCALC foundation tag that actually allows us to see that. And we can also schedule it as well if we wanted to build a schedule that references that parameter. So, not physically modeled at this time. It wouldn't be visible if you cut a section through this footing. We've intentionally kept it as parametric only um, to try and not disrupt any workflows for teams who may not prefer that, if that makes sense.
Yeah, it's good to know that it's still parametric. We have that parametric data. That also helps with key plans as well. Your ENERCALC descriptions for your beam, so your beam name, your column name. You can tag beams
Yep,
in your key plan, and you can quickly make a key plan off those names, which is a
yep,
feature
that's
that
right.
I like a lot. You don't have to
Yeah,
go ahead
that's a great
and
Right.
manually create that key plan. So Seth can show an example of that real quick.
Yeah, I'm trying to think which of these have descriptive names that we created on the fly here. Let's look at our element manager. Well, this one would be an example. More my balcony beam.
And while you do that in the background, I'm just going to answer another question that came
Yeah,
up.
for sure.
We have a question about, do we have similar presentations for ArchiCAD? We do not have a presentation for ArchiCAD. We do not have plans to integrate with additional BIM platforms. So ArchiCAD or other platforms, where ENERCALC for Revit is primarily for Revit
So here's a
tools.
quick example of what Chelsea was talking about. Because this beam, when we saved it in ENERCALC, has a name associated with it, we called it this corridor long joist. And we actually have a tag that reads that parameter. So if you had a calculation plan where you wanted a plan printout to actually correlate cleanly to your calculation package, you can tag just like that and automatically see. And so if I were to relaunch this calculation and change that name and save and close, the tag would follow.
I love that feature. All right, next question up here. Is there a way to map custom Revit families to standard ENERCALC sections?
Yeah, for sure. So everything about ENERCALC for Revit was intentionally designed to be very, very flexible to hopefully work cleanly and smoothly with whatever workflow an engineering team already has in place. So everything that you guys saw us doing today, all this interaction that we were doing with this particular model was all done using out-of-box families, not ENERCALC specific families. So it's not like you have to throw away all your content and do it, quote, the ENERCALC way. All of the mapping that you guys saw where I launch a calculation and it loads in ENERCALC is all done purely based on naming right now. Um, so basically, when I want to launch a 2x6, we're just looking at the fact that it says 2x6, and that's how we're mapping it into ENERCALC. The same is true if you're doing steel design. If it says W8x10, we're not checking the flange width, the depth, and the cross-sectional area. We're just mapping it into ENERCALC as an 8x10. So right now, the approach is all based on instance naming, if that
Yeah,
makes sense.
yeah. So meaning that you can use it with your company's
That's
Revit
correct. So
families that you've created. I'd encourage you to try it out on your company's Revit families. If you are running into anything, please reach out to us. Uh,
absolutely. And
yeah, we want this to be flexible for.
that's the thing that we always want to emphasize is like if you try it once and it doesn't work, the message is not, oh, well, too bad, you should have done it the ENERCALC way. The message would be, hey, reach out to us because we want this to work for your workflow, and we can look at it and find ways to broaden the flexibility and make it work with as many different ways of doing things as possible. Because that's really the big challenge about Revit is it's such a diverse and robust environment where there's so many different ways to do so many different things. Hit us up if you have a problem and it doesn't do exactly what you expect, because chances are that's something other engineers will run into, and we want to broaden our functionality to accommodate that.
Yes. A related question has just come in. If the section was not loaded in Revit and ENERCALC, you picked a new section that wasn't loaded in your Revit project,
Mm-hmm.
what happens then?
Yeah, great question. So, depending on how your BIM manager has things set up, typically everyone will have a location where your loadable content lives. And that's typically specified under File, Options, File Locations, Places. This library directory is the root directory that Revit automatically takes you to when you go to add a new family. If you go insert load family, or if you go edit type load family, this is where Revit takes you. And so ENERCALC for Revit is using this same root directory to go search for content on the fly if you don't happen to have it loaded already. So if I were working on resizing one of these rafters, one of these joists, if I've got a 2x6 and all I have in here is, 2x4s and 2x6s, say the rest of these weren't in here. If I tell ENERCALC I want a 2 by 12 and I hit save and close, it's a two-step process. ENERCALC for Revit will inspect your project file first and see if the see if the 2 by 12 already exists in the project. If it doesn't, then we use that directory where your loadable content lives and we try to go out and find it. Now, if we search to the four corners of the earth and can't find it, you'll just get a little pop up that says, hey, we couldn't find it. And we temporarily put that in a warning state because we weren't able to toggle your size. But that's pretty rare because it's a very robust retrieval process. So you absolutely can load new sections on the fly automatically. The same with steel design. You can start with just one steel section and you can tell ENERCALC that you need a 30 by 90 or whatever. And when you save and close, it's going to get loaded on the fly as long as we can traverse your loadable content. Great question.
Yeah, I want to jump in here. So that's true for your dimensional lumber and your steel sections.
Yes. And
And
that,
then for
yes, that's the
foundations,
footnote that I was, yeah.
yeah, yeah, for foundations, it's actually quite cool. If you enter Calc for Revit, like Seth said, it'll look at your project and see if there's a foundation type that matches the geometry from ENERCALC. And if there's not that geometry that already exists, ENERCALC for Revit will build you a new footing type. So
Yep.
that workflow is pretty sweet. And then for engineered lumber, it is a little bit more of a
Yes.
one-to-one. That content does have to be loaded.
That's right. And so when it comes to your engineered wood products, there is a mind-blowing level of diversity with how manufacturers specify their products, how engineers refer to those products, and how engineers and BIM teams like to build the types and families that contain those products. And so when you try to load a new engineered wood product, like a new LVL or a new LSL or something like that, we do not go fishing in the dark to try and find what you're looking for. We only load from content that's presently in the model if you're trying to load an LVL. So that's the one exception to that question. However, we are prototyping some um, fairly feature complete families that nicely match up against the ENERCALC content. So, for example, we have a whole TJ Microlam group in here. We have TJ Paralam, TJ Timberstrand, Versalam. These all match up one to one very cleanly with what ENERCALC supports. And so we do have those if it turns out that your team is just, you're like, I want to specify these, but I don't want to build my own or it's not practical. Just reach out to me and we can probably get you something that works. We don't deploy those with the installation right now, but hit me up if that's something you have questions about.
Yeah, the engineered wood capabilities are newer, so we're definitely looking for feedback on
Absolutely.
everything, but those especially. All right, we have a few more questions here. I know that we are over on time, so if anyone needs to drop, we appreciate you being here. And we apologize for being over on time, but I do want to make sure we get people's questions answered. So
Yeah,
let's
for sure.
let's knock through a few more of these. If you have to drop, have a wonderful day. Thank you for being here. But let's get through these other ones together. So let's see. It seems that you manually placed a top plate with individual studs to analyze. What about typical wall types? I think this question is kind of going on like, can you just size a typical wall? EnerCalc for Revit is looking at your individual gravity element. So, your
Hmm.
individual beam, your individual column. So that's where that workflow is coming from.
Yeah, so that's a good question, and it's rolling downhill from existing functionality in EnerCalc itself, right? So everything that you guys have experienced today is all springboarding from the fundamentals of how EnerCalc is designed to work. And EnerCalc actually doesn't have a stud wall design module where you're designing the wall as a system, right? We do have NDS wood shear wall, but that's kind of a different animal. When it comes to like a gravity bearing wall, EnerCalc doesn't have a module that does that per se. And so what you do have is the wood column module, which is a discretized individual piece axial compression element. And so that's the only reason why I had that set up the way it was, because that's in harmony with what EnerCalc already does today. But once again, if you guys have feature requests about like, oh well, why don't you guys produce, a wood stud wall module, you know, we want to hear those things. So don't hesitate to reach out. I can check with the engineering team to see if there's already an active feature request for a bearing wall gravity design module as compared to, discrete columns.
Yeah,
But I
we
think
can
that
take a
was
look at that.
fundamentally, I think that was the question, right, Chelsea? Basically, why is it not being
Yes.
designed as a system?
Yeah. And like you pointed out, Seth, that's going to go back to ENERCALC doesn't have a bearing wall
Exactly.
module standalone. We can go ahead and, like Seth said, we can check that feature request. We can submit a feature request on your behalf if we do not see one already. And a couple more questions here. What about footing rebar? Will it automatically upload in Revit like detailed sections? As Seth mentioned earlier, the rebar information doesn't come in as like physically modeled. Reinforcement. So no, you will not get detailed sections for those. And then we have another question about concrete beams and concrete columns. Uh, ENERCALC for Revit currently supports full gravity load path for steel and wood elements. If you would like to see concrete, then that is something that we'd like to hear from you. So please submit a feature request to support at enercalc.com.
Yeah, and I'll just briefly mention on that. We did some development prototyping about, I want to say, about 4 years ago, when ENERCALC for Revit was very, very much in its fledgling stages. We did some work on concrete beam, not on concrete column, but we decided to hold on to that in favor of producing the wood capabilities instead, just because it seems a lot more relevant to a lot of engineers, especially given the discrete component aspect of things. Concrete is not so cut and dried when it comes to discretizing because of the fixity and continuity issues that you have inherent in concrete design. And so it's not as clear how you would do some of the things we did today, where we were just seamlessly flowing from one component to the next. Um, However, there are a lot of highly functional prototypes that our engineering team has tested to do things like simple span pan joist, concrete beams, all interacting with Revit beam families. So that capability is something we've looked at. Let us know if that's something that you guys would love to see out in the wild. Because again, the development pathway, we want to be whatever you guys need it to be. So don't be shy about reaching out with that feedback.
Yes, please. I have a question here from Stephen. Your design for the general footing seemed to have an allowable soil bearing stress that was different than the needed soil bearing stress. Seth, I don't know if you want to pull that calc up or if this is something that we might want to
Yeah,
take offline.
no, that's a great
Um,
question. So, all of those assumptions you can control in the same way you could a normal manually built calculation. And if you do make changes to like changing the allowable soil bearing or what have you, those changes will interop back here to your design properties window. So general footing was not the main focus today, and so we didn't drill down into that much, but we do have a tab for general footing, which includes a whole lot of design rules, including things like your design assumptions and lots of other things. So you can set some default values, and you can also, if you were to launch this general footing calculation into the normal general footing workflow, which I think I have a slide for that here. Um, you would be able to go to the soil allowables and change those values, and that would be retained from one recalculation to the next. So you do have full granular control. We're accelerating the launch process, but we're not tying your hands in terms of what you can control or not control, if that makes sense.
yeah, good point on, you generate the ENERCALC calculation and then you have the full capability to edit that ENERCALC calculation. Mostly the full capability, I guess, but
Yeah.
yeah, things that aren't going to affect your Revit geometry, you will be able to
Yes.
edit in
So
ENERCALC.
there are some things that you'll see locked out. For example, if you have a beam with a fixed span distance, because like those headers that span from wall to wall, right? We can't let you change that span geometry because then it's not clear what we're supposed to do when we save and close. We're not going to move your walls. We're not going to allow ENERCALC for Revit to move columns on its own if you change a span distance or something like that.
Yep. All right, we've got two more questions here. We're gonna knock them out. Setting up loads in Revit will link to ENERCALC. We went over that a little bit earlier. You
Definitely.
can apply loading in the analytical model. We have a couple of videos about that on YouTube. So if you need some more information, I encourage you to check that out. If you have questions after you watch those videos, Seth and I would love to hear from you. So you can email support@enercalc.com.
Absolutely.
And then we have one kind of workflow question here. What would be the best way to get reactions from a joist bearing on a wall, bearing on a beam below? It
Yeah,
sounds
great
like maybe
question.
like the transfer of that wall loading down to our
Hmm.
beam. Seth, what do
Yeah,
you think
so
about that?
even without any future capabilities being added, you could do that today using the transfer post workflow. So just like we talked about coming in here and trying to get the force effects from the ridge girder onto the transfer girder, right? The way we did that was by inserting a transfer post. So if you had a situation where you go, okay, we've got heavy loads on a wall and then the wall lands on something else, um, you can basically synthesize that effect by just inserting a dummy stick frame like a stud and then transfer axial force down from level to level, if that makes sense. And that's really what the transfer post feature is all about, so that you can synthesize those more unusual conditions, if that makes sense.
Yeah. And a good thing to kind of point out in case it wasn't obvious when you are doing that beam calc and you have that transfer post applied, if you have some additional wall weight that you want to apply, you can still apply a distributed load on that beam over
Absolutely.
on your ENERCALC side.
Yep.
So your ENERCALC calcs will be based on the reactions that are coming from Revit and also the manually applied loads that you're applying in ENERCALC. So it can be a mix of those.
Correct. That's right.
Sweet. Well, thank you all for sticking with us. I know that that was a longer one, but it was great to get those questions answered. Thank you guys for coming with questions. Seth loves talking about Intercom for Revit, so I'm sure he's stoked on that.
Absolutely.
Seth, what are we doing next month?
Well, what are you doing next month is the question. So, next month's session, Chelsea will be presenting, right?
Yeah, that is me.
And the topic will be on July 8th, restrained retaining walls. So, that's applicable to basement walls and walls that are tied back and a variety of other conditions. So, Chelsea will be presenting that. We'll look forward to seeing you guys next month to learn a little about earth retention capabilities. And yeah, in the meantime, we will say thank you everybody for being here. We always look forward to these. It's always great to get everybody in here and have a lot of great discussion. Thanks everybody for the great questions and interactive portion. We always love to get questions. So thanks for pitching in on that. And again, if there's anything that we didn't cover for you today that you didn't get a chance to ask or you'd like to dive deeper on, absolutely reach out to the engineering team. We'd love to tackle that.